Okay, now members, let us see how do we handle this equation. So how do we apply the properties and laws of logarithms to solve these questions? Please don't forget to subscribe to the channel. Okay, so solve for x in the following. I give you this, then this, and these others. So the property I'm going to apply here is if we have x to base 2 equal to 3, we get x, we raise it to this power, use the, and then we apply property. So this will be now. Remember, we have this will be x equaling to 2. You get this base to raise it to this power there. So start your x will be 2 power 3, that is 8. The property I'm using is the property where I'm saying if we have x, a to base b equaling to c to be the same as a equal to b power c. This property here, log of a, b equaling to c, the same as e equaling to b power c. You get this power base, we raise it to that, then that's what we have done. So instead of x, you get 2 power this equaling to what is there, as simple as that. Then here, when we have this one, x, 3, and is equaling to this and this, you say if the base are the same, it means that this is equal to this. So there, our x will be 5, then it is. You say if the base are the same and the logarithm are equal, it means that now this and this is the same. Okay, now there, we come to this. We said before we apply any property, the coefficients of these two should be 1. Then instead we are subtracting, then we shall divide. So this will be now log, we get 16, divided by 4. Then we maintain our base equaling 2 and 2 there. Then this, divided by this, then we maintain our base. So there, so that we have log, this will be now 4x equaling to 2. Then we apply this property again. So this will be now 4 equaling to x, then power 2. And then there what happens? We have x squared equaling 4. We get a square root, also get a square root. So our x is plus or minus 2. But therefore we conclude here, x is a 2. Why? A base can't be negative. So x is a 2. Like that. In logarithms, a base can never be negative. That's why we conclude. We get a square root to get two values, the positive and the minus, but we choose the positive because always bases in logarithms at this level are positives. As simple as that. Now, when it comes to this, coefficient 1, coefficient 1, coefficient 1, there we can handle. So we are going here sometimes, so we shall divide. So this will be now log. The base is the same, so we maintain our base. Then you get 3x plus 1 over now x minus 1. The whole is equaling to log 4, 10. As simple as that. And now we say, using now this and this, if the bases are the same, then this is equal to this. As simple as that. Now, these are now 3x plus 1 over x minus 1 is equaling to now a 4. So you see that this is the same, so meaning the whole of this is equaling to a 4. There we just cross multiply 3x plus 1 equaling 4 into x minus 1. We are cross multiplying there. Then this will be 3x plus 1 equaling 4x minus 4. Bring this beside, take this beside. We have now 1 plus 4, and I bring this beside. Equaling 4x. This one now I take this beside and then 3x. The property we have applied here is log of ac equaling log of bc. If these are the same, it means that even they are the same. So from here I start, I have my 5 equaling to x. As simple as that. Okay, we now come to this. You see we are adding. Same base, same base. Here we don't have anything there. You can use many ways, but coefficient 1, same base. We can multiply. So this will be now log of x plus 1 times x minus 2, then equaling to a 1. Here, you can then apply this property here of getting it decided, or you know that log of 10 is always a 1. So now why am I increasing 10? Because I want to make this base uniform. That's why I'm going to say if it was base 2, I would have introduced here 2. But because to base 10, that's why I also making this base be 10. If this is 10 to make it a 1, I don't want to change anything here. So that's the idea I can use. Remember, the whole of this is multiplying. So, you see that either you say this equal to this or you use this. It's up to you. So this power this will be equal to this. So x plus 1 into x minus 2 will be equal to 10. Now power 1. Or someone will say from here log of x plus 1, then x minus 2, 10 is equal to 2. Now this one, I introduce this in terms of log 10, 10, because it will be 1, which will be the same there. Then you say same base, means this is equal to this. So x plus 1, x minus 2 will be equal to 10, as you see in that step. So here we can multiply. This time with this we get x squared. Then this time with this we get minus 2x. Then this time with this we get x minus 2 equal to 10. So this will be now x squared minus x minus, when I bring this beside it becomes a minus 10 equal to 0. So this will be x squared minus x minus 12 equal to 0. Now we have seen how to solve radical equations. You ask yourself two numbers, you multiply, you get negative 12, you add, you get this. Those are x squared minus 4x plus 3x, then minus 12 equal to 0. When you simplify this, go back to our negative 1. And so this will be x minus 4 into x plus 3 equal to 0. So our x is negative. Okay, our x is 4, or our x, when you equate this to be that. But we say, when you look here, x can't be a negative, because when you put here negative 3, it will be having now the whole of this as a negative, which will give you a much better. So there I conclude with one value only. So there I conclude with one value only, sorry. We conclude that here, our x is 4, or our x is negative 3. But we say when you put in, instead you test back. When I put here negative 3 to be negative, plus 1 to be negative 2. And log of a negative does not exist. So that's why I'm adding here, and I conclude that this will be a 4. If this will, when we put here, we'll be having a positive, then that will be okay. But it's when we put the result is negative. That's why I'm concluding with only one value. When I come down to this, it's saying if x, y is equal to this, and this is equal to this, find x and y. Okay, we start with this. So our 2 log y x equal to 1. It means that now, before applying the property, this power should be up there. Meaning that now, my log y, when I put down this power here, to become a square. I remove it using the other property, equal to 1. Which property am I using? N, this property, n log mb, the same as this power comes here. Comes at the top of this number, get log of n power mb. That's the property I'm using. Then here, you can apply this property here. That if this, then you can that one. So it's that our y squared will be equal to x. Now power 1, you get x power this. So you get x squared. Your y is equal to x. Now, from here, we are given that x, y is 8. But you know that your x is y squared. So my x is y squared into y equal to 8. When I multiply here, I get y cubed equal to 8. So this is the same as y cubed equal to 2 cubed. If powers are the same, it means that also bases are the same. So my y is 2. So if my y is 2, come here and get x. Your x is y squared, which will be 2 squared. So that your x is going to be 4. It is. So here, before we apply this property, the coefficient here should be 1. That's why we are removing this. Then we take it to that side as simple as that. If powers are the same, it means that also bases are the same, not that. Okay, let us do this. Solve for x and y if log of this is that. and then log of this is this. Okay, so you handle one by one. I start with the other log is equal to 2. It means I'm going to have to use this property here. Log to base b is equal to this, the same as we get this equal to this power this. So this will be 2x plus y equal to 3 power 2. This will be 2x plus y. This is a plus equal to a 9, equation 1. I also add to this one here. Log plus 3y 2 equal to a 3. The same idea, get this power this. You have 5x plus 3y equal to 2 power 3. Which property are we using? Log a b equal to c. We get a, get this b power this. That's what we are using. So that our 5x plus 3y is equal to 8. Correct equation 2. Now solve this simultaneously. How am I going to solve this? So that I need to multiply here with the 3, so that it's the same there. So what do you do? You get your 2x plus y equal to 9, then your 5x plus 3y equal to 8. So what you do? You multiply this 3 here, then you multiply this coefficient there. What do you get if you multiply? When you multiply, this time this you get 6x, this time this you get plus 3y equal to 27, 3 times 9. 1 times this you get 5x plus 1 times this you get 3y equal to 1 times 8, we get 8. Now is that the coefficients of y are the same. We are multiplying this here and the coefficient of y here in this equation here to make the coefficient be the same. Is that the same signs? We subtract. 6x minus 5x, we get x equal to 2. Okay, 3y minus 3y, we get 0. 27 minus 8, we get 19. 19. So 9x is 19. So if my x is 19, I come and I get my y from here. From 1, so that my y will be 9 minus, if I take this side, 2x. If I take this side, so my y will be 9 minus 2 into 19. This will be 9 minus this side and this, you get that 8. And by this one, you get the negative 20, negative 29. It is, that's our y. So therefore, our x is 19 and our y is negative 29. So you have solved. So that's how we use logarithms properties to handle these numbers. I wish you well.